Okay, Bismillah ar-Rahman ar-Rahim. We did this problem. Now we'll go to the next one. Yeah, this is not diagonal, it's not nilpotent, so I need to find A80 as what? As 5T times 5 inverse of 0. Also, it's not this 0, 0, 3, 0. Is it diagonal? Yeah. Okay, so this can be written as D plus nilpotent. No need to do it through this, I think. Let me check. That will be 1, 0, 0 minus 1 plus 0, 0, 3, 0. Where this is an important, yes. Okay. So e to the power at will be e to the power dt times e to the power nt. If n 0, 0, 3, 0, what will be n square? 0, 0, 3, 0 times itself. Will that make it nilpotent? Let me check. That will be 0. That will be 0. That will be 0. That will be 0. So it's unimportant. So e to the power nt will be I plus nt plus 0. And that will be 1, 0, 0, 1 plus 0, 0, 3, 0 times t, which is 1, 0. This is 3t. This is 1. So what about e to the power dt? That will be et 0, 0, e minus t times this one. 1, 0, 3t, 1. Is it? Yeah. N square is 0. Oh, sorry, this is minus 1. Oh, no, this is the I. Yes, yes, correct. So 1, 0, 0, 0, 0 plus 3t, 1, 0, which is 1. Okay. Now do the multiplication. That will be what? Et, this times this. It is 0, 0, 3t, e minus t. And the last one, e minus t. And that will be my exponential matrix. Yeah. Clear. Now let me move to the second one. Yeah. This seems to be nilpotent. Let me check. A square, 1 minus 1, 2, 1 minus 1 minus 2, 0, 0, 0, times 1 minus 1, 2, 1 minus 1 minus 2, 0, 0, 0. Be careful in the calculation. First row times first column, that will be 0, 1 minus 1 plus 0, minus 1 plus 1 plus 0, 2. Here, be careful. 2 plus 2 plus 0, that will be 4. Okay, 1 minus 1 plus 0, 0. Minus 1 plus 1 plus 0, that is 0. Be careful here. 2 plus 2, which is 4 again. Now 0, yeah, for sure this will be 0, 0, 0. A cubed will be what? 0, 0, 4, 0, 0, 4, 0, 0, 0. Yeah, is it 4? Last column. 2 plus 2, yes, it's 4. First one, 2 plus 2, yes. Times A itself, 0, 1 minus 1, and this is 0, 0. That will be what? This times this is 0, this times this 0, this times this 0, and the same thing for the rest. So it's a nilpotent matrix. Nilpotent matrix. What will be e to the power at? That will be I plus at plus a square t square over 2 factorial plus 0. And that means AAT 100,010,001 I plus A, be careful here, minus 1 minus 200T plus 004 004 000 T square over 2. That will be what? Have 1 plus T. Okay. First row times the second column. No, first row, 1, first element, first element, first element, first element. That 1 plus T. Second element in the first row, that will be 0 minus T, that is minus T. Then 0, 2T. Plus 4T square, plus 2T square. This is 4 times T square over 2 plus 2T square. Okay. Now, second row, first element, this is T. 1 minus T. Then I have what? Minus 2T plus 2T square. The third column, 0, 0, 0. That is 0, 0, 0, 0, 0. And this is 1. Okay. What I need? We need AAT times this vector, 0, 0, 5, which is 5 times the last column. But let me do it in details. 1 plus T minus T, 2T plus TT square, T, 1 minus T minus 2T plus TT square, 0, 0, 1. And that will be what? This times this. So first row, give me just the last column, which is 5, 2T plus 2T square. T, second row, times this, the last column, 5 times the last column. And the same thing, 5 times 1. So I can take 5 common factor. 2T plus 2T square minus 2T plus 2T square and 1. And this is answer. Compute E is minus T. First, I'll find e to the power at. E to the power at is what? A is the diagonal. I know A. So e to the power at will be e2t 0, 0, e minus 3t. What will be e to the power minus at? So instead of t, I will write minus t. That will be e to the power a times minus. So instead of t, I will write minus t. So that will be e to the power minus 2t, 0, 0, e3t. That will be my answer. Or, in other words, you can think of it as e to the power at. Yeah. Or let me think about it another way. We say b equal minus a. Another way. Another way. Think of b equal minus a. So e to the power minus at is e to the power bt. And what is b? B will be minus 2003. So that's diagonal e minus 2t 00 e3t. Yeah, which is the same thing. Okay, using an exponential matrix method, using exponential matrix using the exponential of a matrix method, if the general solution system is this is equal to this, then that means I know the system, the solution EAT times the constant vector. So this is my EAT. So I need to find that. I know A is 0, 0, 0, 3, 0, 0, 5, 1, 0. It's an nilpotent. It's lower triangle, so it's an nilpotent. A square 0, 3, 0, this is 0, 0, 0. Now we need to be careful. 5 times 0 plus 3, that will be 3. 0. Oh, be careful here. This times this, yeah, it will be 0 still. And the last one will be 0. Now a cubed, it will be 0. You can check it. We did something similar before. So EAT, which I'm looking for, yeah, a plus AT plus a squared, t squared over 2 factorial plus 0. And that will be 1, 0, 0, 0, 1, 0, 0, 0, 1 plus a, which is 0, 0, 0, 3, 0, 0, 5, 1, 0 times t plus this one, 3, 0, 0, t squared over 2. Okay. So that will be what? 1 plus 0, 0 plus 0, 0 plus 0, 3t. Then I have 1 plus 0, that is 1, 0 plus 0. Then 0, I have 5t plus 3t square over 2. Then I have what? 0 plus t, and the last one is 1. Okay. Okay. So 1, yeah, this is 1. This is 0. This is 0. This is g of t. Okay. This is 1. Yeah, this is 1. This is 0. This is h of t. This is f of t. And that is 1. Correct. So now what he wants g at 2 plus h at 2 plus f at 2. We have everything at 2. So h at 2, it will be 5 times 2 plus 3, 2 square over 2. That is g at 2. H at 2, it will be, this is g at 2. No, this is, yeah. There is no difference, all of them plus, but let me make it. This is 3 times 2 plus. This is 5 times 2 plus 3, 2 square over 2 plus 2, which is f at 2. So that will be 6 plus. This is 10 plus 16 plus 2, which is what? 24, which is this answer. Possible fundamental matrix for this system. Yeah. Yeah, so it means you need to find 5, and to solve it, then we'll do the we'll find the fundamental matrix. 6 minus lambda 2, 5, 3 minus lambda. That will be what? That will be lambda square minus 9 lambda. Okay. Plus 18 minus 10, which is lambda square minus lambda plus 8, which is lambda minus 1 times minus lambda minus 8. So it's minus 9. Okay. That equal to 0. So I have lambda equal 1 and 8. Now for lambda equal 1, what are we getting? We are getting what? 6 minus 1, 5, 2, 5, 2. I have 5k1 plus 2k2 equal 0. So k2 equal minus 5 over 2k1. Let k1 equal 2. I'm getting k2 equal minus 5. So v1 equal 2 minus 5. So x1, 2 minus 5 e to the power t. Yeah, which is 2et minus 5et. Now, for lambda equal 8, what I have, 6 minus 8 is what? 6 minus 8 is minus 2, and 2. And then I have 5, 3 minus 8 is minus 5, times k1, k2 equals 0, 0. So I have what? Minus 2k1 plus 2k2 equals 0, or 5k1 minus 5k2 equals 0. Okay, so I'm getting that k1 equal k2. Let k2 equal 1. So k1 equal 1. So v1 is 1, 1. v2, I mean, x2, 1, 1, e at t. So x2 will be equal e at t, e at t. So what is 5t? It is x1, x2, which is 2et minus 5et, e at t, e at t. Okay. This is wrong. This is wrong. This is wrong. We know that it's each solution, and scalar multiple of it is also a solution. So multiply by minus here in x1, or it can be minus 2et 5et. You multiply by minus sign. You can multiply by any number. So this is okay, but this is wrong. Since I know that k1 equal k2, so I needed the same. So it can be 1, 1, or it can be any other value. Like in this case, you make it 2, 2, which is okay. So x2 equal this, or x2 equal 2. Let me make it here. Or x2 will be 2 EAT, 2 EAT, any value. But these two values should be the same. So this is okay. So this is my 5t, a possible 5t. Okay. Can put that, can 3, 3, 5, 5. So it depends on the answers. Now he gave me 5t in this case, and he wants what? He wants e to the power 80. So for sure, I will do this formula. Okay, so it will be phi at 0. That will be 1, 3, 1, 2. Correct? Yeah, e to the power 0 is 1. So what will be determinant of phi at 0? That will be 2 minus 3, which is minus 1. So it will be phi of 0 inverse. That will be minus 1 times what? 2, 1 minus 3 minus 1. That will be minus 2, 3, 1 minus 1. So EAT will be this matrix, e to the power 5t, which is this. Times the inverse. And that will be minus 2 e to t. This row times this column plus 3 e3t, the first row times the first column, and the first row times the second column, minus. Then the second row times the first column, and the second row times the second column. Now let me check what will be the answer. Minus 2 plus 3, 3 minus 3, minus 2 plus 2, and 3 minus 2. So this is my answer. Yes, correct. Okay, and let's find e to the power 80. Is this an important? Let me check. A 6, 4, minus 9, minus 6. What will be a square? That will be 36 minus 36, 0. Good. 24 minus 24, 0. Minus 54 plus 54, 0. Minus 36 plus 36, 0. So it's an nilpotent. E to the power 80 will be I plus 80 plus 0. So it will be 1001. What is A? 6, 4 minus 9 minus 6t. And that will be 1 plus 60, 40 minus 90, 1 minus 60, which is this one. Easy one. A possible fundamental matrix. It means I need to solve this. So I need A minus lambda I, 2 minus lambda minus 1 minus 4. Then I have 2 minus lambda. That will be lambda square minus 2 lambda minus 2 lambda minus 4 lambda plus 4 minus 4. That's lambda square minus 4 lambda, which is lambda times lambda minus 4 equals 0. So lambda equals 0 and 4. Now for lambda equals 0, what are we getting? Minus 1 minus 4, 2 times k1, k2 equals 0, 0. So we're getting 2k1 minus k2 equals 0. Yeah, very clear the two equations are the same. So I'm getting k2 equal to k1. Let k1 equal 1. Getting k2 equal 2. So v1 will be what? Yeah, 1 and 2. And x1, 1 and 2. E to the power 0 is 1. So no need to worry about. For lambda equal 4, 4. Yeah, what we have? 2 minus 4, that's minus 2 minus 1. Minus 4, 2 minus 4, that is minus 2. And that implies minus 2k1 minus k2 equals 0. Minus 4k1 minus 2k2 equals 0. So I have k2 minus 2k1, and this is the same equation. So let k1 equal 1. So k2 equal minus 2. So v2 will be 1 minus 2, and x2 1 minus 2 e4t, which is e4t minus 2 e4t. So it will be 5t. 5t will be x1, x2, just to list them. And that will be what? 1, 2. That will be e4t minus 2 e4t. What is this one? Okay, 5t is this. Find e to the power at. E to the power at will be what? 5t, 5 inverse of 0. I know that. So it will be phi at 0. Phi at 0 will be 1, 4, 1, 3. So the determinant of phi at 0 will be minus 1. 3 minus 4. So phi at 0, the inverse of that will be minus 1. This is 3, 1, minus 4, minus 1. That will be minus 3, 4, 1 minus 1. E to the power at will be 5t, which is this, times phi inverse. That will be what? Yeah, be careful. Now, minus 3at, first row times first column plus 4e to t. Yes, first row times second column, 4et minus 4e to t. Now this is minus 3et plus 3e to t. And then I have 4et minus 3e to t, which is this answer. So honestly, 4 minus 4 minus 3, 3, 4 minus 3. Okay. What you want? You want the form fundamental matrix. So it means I need to solve this. Yeah. So A minus lambda I, that will be what? 2 minus lambda 1, 2, 0, 1 minus lambda 2, 0, 0, 3 minus lambda. So very clear, that will be 2 minus lambda, 1 minus lambda, 3 minus lambda. So lambda 1, 2, 3. Okay. I need to find the solutions. I just listed. Okay, so for lambda equal 1, he started with 2. Yeah. And then 1 and then 3. So let me start with 2, like what he did. That will be 0, 1, 2, 0, 1 minus 2, that is minus 1 and 2, 0, 0, 1 times k1, k2, k3 equals 0, 0, 0. So what are the equations? K2 plus 2, k3 equals 0, minus k2 plus 2, k3 equals 0, and k3 equals 0. So for sure, k2 equals 0, and k1 is free. So I let v1 to be 1, 0, 0. Let k1 equal 1. So x1 will be 1, 0, 0, e to t. In other words, e to t, 0, 0. So this is x1, which is true for all of them, well, except this one. So this is wrong. Okay, now for lambda equals 1, then he did the 1. Okay, what I have 2 minus 1, 1, 1, 2, 0, 0, 2, 0, 0, 2 times k1, k2, k3 equals 0, 0, 0. So what we have? We have k1 plus k2 plus 2k3 equals 0, and 2k3 equals 0. So here I have k3 equals 0. And from there, I have that k2 equal minus k1. So let k1 equal minus 1, you get k2 equal 1. So v2 will be what? Minus 1 and 1. And x2 et, which is minus et. Sorry. And 0, 0. It should be 3 by 1 vector. Vector with 3 elements. So I have minus et is okay, this is okay, this is wrong. And this is wrong too. Now we'll come to the last one. For lambda equals 3. What are we getting? 2 minus 3 minus 1, 1, 2, and 0. 1 minus 3, that is minus 2, 2, 0, 0, 0 times k1, k2, k3 equals to 0, 0, 0. Now I need to deal with this system. Is it correct? 2 minus 3, 1 minus 3, and 0. Okay. So I have minus k1 plus k2 plus 2k3 equals 0, minus 2k2 plus 2k3 equals 0. Oops. So I have k2 equal k3. Plug it here. That gives me what? Minus k1. Oops. k2 equal k3 plus 3 k3 equals 0. So k1 equals 3 k3. So v3, I let k3 equal 1. v3 would be what? 1, 1, 3. So x3 will be 3, 1, 1, e to the power 3t, which is what? 3e 3t, e 3t, e 3t. which is, this is wrong. So this is really my answer, where I will write 5t as x1, x2, x3, and that will be, let me write the solution, T2T 0, 0. Second one, minus ET0. Last one, 3E3T, E3T, E3T. Yeah. Okay. Now he wants e to the power 80, but this is very clear. It's a diagonal plus a nilpotent. A will be d plus n. And he wants e to the power 80 equal to what? Okay, so e to the power 80 will be e to the power dt times e to the power nt. Yeah, d is what? 2, 2, 2, 0, 0, 0, 0, 0, 0. So e to the power d t is e to t 0, 0, e to t 0, e to t. Now for the nilpotent, n is what? 0, 0, 0, 1, 0, 0, 2, 3, 0. That will be my n. Very clear, a equal d plus n. Huh? If you add them, you will get a. So it will be n square. It will be 0, 0, 0, 1, 0, 0, 2, 3, 0 by itself. And that will be, oops, that will be what? 0, 0, 0. First row, second row times first column, that will be 0. First row, yeah, that will be 0, 0. Now here we need to be careful. That will be 3. 2 times 0 plus 3 times 1 plus 0 times 2, which is 3. And the rest are 0. Very clear, n cubed will be 0. Check. So it will be e to the power nt. That will be I plus at plus a squared t squared over 2 factorial plus 0. 1, 0, 0, 0, 1, 0, 0, 0, 1 plus n, which is 0, 0, 0, 1, 0, 0, 2, 3, 0, t plus 0, 0, 0, 0, 0, 0, 3, 0, 0, t squared over 2 plus 0. And that is what? 1 plus 0, 0, 0, 0, 0. Yeah. And have 0 plus t, that will be t. 1 plus 0, 1, 0, 0. Then I have 2t plus 3t squared over 2. Yeah. Let me move this column a little bit. This will be 0, 0. And this is 1, huh? 1, yeah. The last one is 0. Now this one will be what? 0, 3t. And the last one, 1. Now it will be e to the power 80. It will be this matrix, 1, 0, 0, t, 1, 0. No, it will be, sorry, this matrix, it will be edt times ent. So you have e to t. It's a diagonal, so it will not make a difference, but okay. Times this matrix, 1, 0, 0, t, 1, 0, 2t, 3t, 1. And that will be this time this e to t. First row, second column, or third column, that will be 0, 0. Let me give it some space. Second row, times the first column, that will be T, ET. T, EDT. For a second column times the E to T, E to T. Then the second row times the last column, that will be 0. That will be, yeah, this expression, 2T times E to T. And then this times that will be 3T E to T. And the last one, E to T. Yeah, I can take e to the power 2T outside as a common factor. And they have what? 100 T 10 2T over 2 and 3T and 1. So this is my answer. Actually, you can work this since D, D equal, yeah, and this is, by the way, is this one, is the A and T. Since D equal alpha I, where alpha equal to, alpha equal to, then e to the power dt will be e to the power 2t I. So e to the power at will be e to the power 2t I e to the power nt. And I times e to the power nt is only et, e to t times e to the power nt, which is we get here. Yeah, so this will be my answer. Yeah, that will be my last question. Okay, I need to solve the system. I need to use this 5t phi inverse at 0, because this is not important, nothing. Yeah, okay. So I need to solve the system. I have a minus lambda I, that will be 2 minus lambda, 2 minus lambda minus 1, 4 minus 2 minus lambda. And that is what? Lambda square minus 2 lambda minus 2 lambda gun minus 4 plus 4, which is lambda square equals 0. So lambda equal 0, 0. Okay. For lambda equals 0, we have this. We're very clear we have only one eigenvector. What is it? I don't care. So we need to choose u1, a minus lambda I square u1 equals 0, but a minus lambda I u1 not equal to 0. Okay, how to do that? I notice a minus lambda I is this, and a minus lambda I square, that will be 0, 0. Using Cayley-Hamilton, it's okay, I can do the calculation. 0 minus 2, 0, 8, 0, 0. So it's 0, 0. So I can choose let u1 be 1, 0. You have to make it easy. Can't choose anything. Actually, this one, it will work for any u1, but also this one. Yeah, when make it this one, I need the first column to be non-zero, which is the case. And then I have u2 is a minus lambda I times u1. So I need u1 just to avoid, yeah, to avoid multiplying it by a minus lambda I, make it 0, which is not the case. Also, when I find u2, I get that. I can check that also. So I do two things at the same time. That will be 2 and 4, not equal to 0. So I am okay. So I have x1 is u2 e to the power 0, which is 1. So it's u2, which is what? 2, 4. And x2 is u2t plus u1. And that is 2, 4t plus 1, 0, which is 2t plus 1 and 4. What is 5t? Is it just to find 5t? 5t will be 2, 4, and then 2t plus 1, 4. Okay, this is 5t. Still, to find e to the power 80, I need to find this. So I need phi at 0. And that is what? 2, 1, 4, 4. So determinant of phi at 0 will be equal to 4. So phi inverse at 0 will be what? 1 over 4. This is 4, 2 minus 1 minus 4. Yeah, what a calculation. Okay. That give me what? 1 minus 1 over 4 minus 1 half. What is A80? I hope, I mean, there was no mistakes in the calculation. It will be 2, 4, 2t plus 1, 4 times this matrix. Let me see what I'm getting. Okay. 2 minus 2t, very strong, then second column. I'm getting the same answer. Is the mistake. Sorry, this is 40. This is 40. Yeah, this is the last question for this group. Yeah. Yes, I need to be sure about the calculation. It's not a calculation, nothing here to worry about. That will be 40. So phi at 0, it will be 2, 1, 4, 0. Okay. So determinant of phi at 0 it will be minus 4. So phi inverse at 0, it's minus 1 over 4 times what? 0, 2, and minus 1 minus 4. That will be 0, 1 over 4, 1 minus. Yeah, hopefully there are no other mistakes. Yeah, that will be 2t plus 1, 4, 4t times this matrix, 0, 1 over 4, 1 minus half. Let me do the calculation. That will be what? This 1 times this, that will be 2t plus 1. Okay, good. This, it will be half minus t minus half. Perfect. This one will be 4t. Good. And this one will be 1 minus 2t. So what are we getting? 1 plus 2t. Here minus t. Here 4t. Here 1 minus 2t. Which is this answer. Good. Now the next video I will do questions from the book. So let me stop the recording. I think we did a good number of questions. Thank you.